Okay, this is Mr. Peterson. We're looking at the notes for section in Algebra 2. And in this section, we're going to learn how to solve both exponential and logarithmic equations. These on this front page are just exponential equations. You can see that they all have some base and a power. Now, the first goal that we have here is to isolate that base and exponent. So we need to get this 5 to the x by itself. I'll add 4 to both sides. And that'll take me to 5 to the x equals 7 in this problem. And on this one here, I'll come back to this, but we're going to have two steps here. We're going to take the 8 over and subtract it. And that's pretty hard to see this, but this negative sign really means times -1, and it's not part of the base, so we have to isolate even that and divide by -1 here, and now we have our base and our exponent all by itself. Okay, now I'm going to finish these two problems. Part of the process will actually be checking it also. So what you're going to do here is unravel this and make a logarithmic statement out of it. So log base 5 of 7 equals x. Go around the world like that. But the faster way is to just put your base on the other side in the other format. So the base here is 5, and you're going to just put it as a logarithmic statement like that. So log base 5 of 7 is x. But if you just take the base 5 and bring it over here as a log base 5, you'll get there quickly. Now we're supposed to round all these answers here to 4 decimal places. I believe your homework wants 3 decimals, but I'll do the 4 that's requested here. So if you'll let me clear my calculator out, I'm going to go to the mode key and preset that rounding for decimal place accuracy. Now when I get this answer here, log base 5 of 7, I'll find it with 4 decimals of accuracy. Your calculators have math, alpha, math. You can get to that menu really quickly and fill it in, and you've got your value of 2.2019 or 1.2019. I read it wrong, but anyway, you saw it on the calculator, and that's the correct one. At any rate, you want to now store that as x, and then type the original problem. On the left side, now that I have it typed correctly, I should be getting 3, and that worked out just fine. You'll see me on the next problem find the answer and store it at the same time. Now, if you're working with a TI-83, you're going to have to type this one using the change of base formula, and it would look like this. Common log of the big number, 7, divided by the common log of the base 5. So these are both base 10, but we're using base 10 to find base 5. And you get the same answer, 1.2091. which then you would store and check. Okay, the next one here, we're going to take the log base 2 of 13 equals x. And you can see I'm just going to take this base over to the other side of the problem as a logarithmic base instead of an exponential base. And we're going to get, let's see what this gives us. You can do math, alpha, math to find this. 213. If that doesn't work, oh, I forgot I was going to store that at the same time, so let's do that again. Math, alpha, math, 3 or 2 and 13, and I'll hit the store for x. Oh, having trouble. The store for x option, and it not only displays the answer, rounded answer, but it sets it up as being already stored for x, so we can check it. So 8 minus 2 to the x gives -5. So that's a legitimate answer. And once again, I'll show you how to type this on a non-TI-84 calculator like an old TI-83. or maybe a TID4 with an old operating system. You would simply say common log of the big number 13 divided by the common log of the old base. We're using base 10, that's the old base, base 2, and you get the same answer. All right, next one here, we have to isolate the exponential part, and that's already done for us, so we're ready to move on here. X minus 5 is the logarithm base 3 of 8. You can see I took this base on one side and made it a logarithmic base on the other side, and that's just simply going around the world. Log base 3 of 8 is x minus 5. Now we'll add 5 to both sides. And estimate the answer and store it as we do it. So you can do math alpha math, or the other way to do this here is the F2 menu, which is alpha window, and it's the 5th one down, alpha window 5. 3, 8 plus 5 stored for x as I find it. 6.8928. Since it's already stored, I'm ready to type this left-hand side here. Hopefully it equals 8. And it did. If this is off by 10,000ths or something like that, don't worry too much about it being slightly off. Okay, we have to get the exponential part by itself here, so I'm going to divide both sides by 5. Oops. 4 to the 3x is what I meant to get there, and 6 over here. And all I did is divide this 5 off both sides. Now, write the 3x, and the base comes over to the other side in the other format, this time logarithmic format. And we'll divide both sides by 3 here to finish the job. So let's find out what log base 4 of 6, all divided by 3, gives. Math, alpha math. There's my log base 4 of 6. Divided by 3, stored for x. 0.4308 is the supposed answer, and I'm going to check it by typing the original problem just as it appears. And we're hoping this gives 30. And we're good. Okay, we're on a roll here. All right, 6 to the 2x minus 3 power minus 8 is equal to 5. Let's isolate the base by adding 8 to both sides. Now we've got the base and power by itself. And over here, 13. So I just unravel this. Log base 6 of 13 is this number. You'll see me writing that eventually here. But it's just going to look like I'm writing this base 6 on the other side as a logarithm. And later you're going to go the other way. You're going to write logarithms as the other type of base. All right, now we're going to add 3 to both sides. And then divide by 2 here. Notice you have to divide the whole thing by 2. So let's type this. Probably a good idea to use the fraction key now. So alpha F1, enter. And let's go math alpha math. And I'm going to store that as I find it. And that turns out to be 2.2158. Since it's already stored, I can just type the left side. And it should equal 5. And we're in business here. It does equal 5. Okay, we got one more left in this series here. Get the base by itself. This 3 to the 2x you got to isolate. So subtract 4 off both sides. And divide by negative 1 on both sides. A lot of people will skip that step. They don't realize that this negative sign is like multiplying by negative 1. So you have to strip off that. And now you unravel it. Log base 3 of 2 equals 2x. But I'm just going to write the 2x over here and put the logarithm on the other side with a matching base, base 3. And now divide by 2 here to find x. Alright, I'm going to set up a fraction key here. Alpha, F1, enter. Math alpha math 3 and 2 and 2. We'll store this value so that it's set up for checking. Approximately 0.3155, and I will now check it. 4 minus 3 raised to the 2x power should equal 2, and we're good. Okay, so that does it for page 1 of the notes.